All right, there we go. All right, so we have quite a few people, and we are expecting around 40 people in the session. All right, we are expecting because whenever there are 200 people sign up, so around 50 people generally come to the sessions. All right, and and we generally have these brilliant audiences in our free webinar. Okay, so feel free to introduce yourself. I may not be able to read out everybody's introduction, but I'll go through your introduction maybe after the session. All right, great, great. Again, let me do a little introduction. So the dynamics of the sessions are like this. So first half we will spend understanding big data. Then at around 10 o'clock, we will take a 10 minutes break. Again, let me set the expectations right. It is a 3 hour session. Okay, 3 hour session with a 10 minutes break. And second half, we will cover the understanding of the Spark. So we will cover less of big data today, but more of a Spark. And so this session is also being recorded, and recording along with the presentation will be shared with all of you. Okay, so if you want to take notes, you can just take a screenshot and paste it in some WordPad. But nothing to worry. I'll be sharing the presentation and the recording with all of you. All right. If you have to ask questions, please, because everybody except instructor, which is me, everybody is muted. So please ask your questions by typing in the questions window. Instructors will read out the question before answering. And And to get better answers, keep your messages short and avoid chat language. All right. This is our first session out of 11 sessions. Rest of the 10 sessions are for the paid course. This one is open for all. And it suffices as the introduction into big data technologies. Okay. It also helps us setting the expectation from the course, right? All right, and even if you are not from development background, still we strongly recommend session number 1 for all of the people. Rest of the course will have fewer attendees, and you will be able to see other people's question. All right, right now in this one I'll have to read out the question because this go to webinar doesn't allow us to show the questions. Okay, so first of all, welcome to Know Big Data. No Big Data's basic premise is to have expert instructors. Rather than anybody becoming the instructor, we have a very stringent guideline. All right. Instead of having, um, we focus on better instructor, more hands-on person, instead of more um, practitioner of as an instructor. So we prefer a hands-on one over the one who has been experienced instructor. And the other unique selling proposition for No Big Data is our Cloud Labs platform. Cloud Labs platform is something which we give the full environment to our students so that they can start learning online instead of downloading, installing, trying to get through the firewall and all of that. Instead of struggling with all of that, we have figured out that we can provide everything out from the browser itself so that there is no hesitation, no uh, no delays in learning. This is something which we found very helpful, and we have also started licensing it to other instructors. So if you are an instructor, you want Cloud Labs for your student, reach out to us, and that is something which a lot of other companies are using from us. All right. So, and in case you are just interested in Cloud Labs, you are not, you don't want the training, I mean the live training, which is completely okay for us. And so feel free to reach out to us if you are just interested in Cloud Labs. Next is the lifetime access to the learning management system. So all the recordings, presentations, assignments, quizzes, and project work, everything is inside learning management system, and we will keep it lifetime access to all our students. Then real life project is generally based on a real life problem, and those people who qualify, who finish our normal work, they generally, I'm sorry, yeah, so those who qualify for our normal certificate, they only qualify for the real life project. And we provide you a course completion certificate, and we provide a 24 by 7 support over email. And we have formed a group of alumni for No Big Data. We provide a little bit uh, job postings, and then we keep you updated with the complimentary sessions and newer technology introductions. And we continue to stay connected with our alumni. All right. So this is the course curriculum. It includes all the technology surrounding Spark. And if you don't understand any of this, do not worry. We will explain to you each and every part of it. All right. So let me just go through your introductions. I see there are a lot of introductions. Okay. So Vivek's question is, how many of us are here now? Let me check. Okay, right now there are around 33 people. And we have Ram. Ram is from Cove Ventures, attending from UK. Welcome, Ram. I hope you will like the session. We have Santosh from Apnomic Systems. Welcome, Santosh. We have Nishant, who is working for Global Logic Bangalore. Welcome, Nishant. I'm sure you will find it helpful. And hi, Satya. And we have Kiran. Kiran is works on virtualization and cloud computing, and is learning big data. Welcome, Kiran. You will definitely find it useful because you must have realized that cloud and virtualization have changed the way computing works. We have Satya from Information Service Group. Welcome, Satya. Great, great. Feel free to introduce yourself. All right. About myself, I did my graduation in 2002, around 13 years from now. And there I did my BTech. And afterwards, I joined a company called DE Shaw. At DE Shaw has been a good technology company and and before Google's and Amazon's, they were handling the big data systems before even the term was coined. All right. We had a 10,000 node cluster at that time. From 2006, afterwards, I started a company called T-Bits Global. We built an enterprise-grade document management system. Afterwards, I joined InMobi, where I churned a database, the data of around 200 terabyte to build the recommendations. After InMobi, I joined Amazon, and there I built something like a Apache Storm to do the stream processing, and that's being used by multiple teams now. All right. So other than helping Amazon with the product detail page. And then in 2014, last year, I started No Big Data. All right. All right. We have one more person, Mahesh from Bangalore. Good. Welcome, Mahesh. All right. So we start with a trivial question called, what is big data? It's not about the definition of big data. It's just that I want to set my definition right, so that your expectations and the expectation from course is very, very clear to all of us. All right. So, okay. So what is it that you understand by big data? A quick one, just first 3 4 answers would be sufficient enough for me. All right. Hello, Giri. Giri is also from Bangalore. All right. Vikram says that it's a petabyte of data, which is huge volume. Satya says analyzing structured and unstructured data in real time for business insights. Okay, so we have got two answer. One is huge data, other is real time insights. Okay, and Ram says data which is not regular structured variety. So we have got three answers: volume, velocity, and third one is variety. Interesting. And all right. Okay. So Sonu says data with the variations. Ram says need not be excessively large, unstructured. Mahendra says data which is not being processed is required timings by current data. Okay. All right. Good. Good. All right. So we have got great questions, and now we have. All right. Mahesh says massive amount of unstructured data. So almost all the answers you have already given. All right. So in our the way we will deal with big data is it's a data of very big size that you cannot process with usual tools. When I say usual tools, it means your usual file systems, your usual databases like MySQL, MS SQL, and for that you require distributed architecture. So more than tools, it's also the hardware bottlenecks. Okay, one is that you are not able to use your existing tools. Second is the hardware is not allowing processing of that kind of data, and that's where you realize that you require multiple concurrent systems to solve your problem. The data could be of any form, not only structured, but it could be unstructured also. All right. Correct. So here there are two important points. First is you could not do using your usual tools, and you needed the distributed architecture. Now, there is a common question that what exactly is distributed architecture? Distributed architecture is where you take multiple computers and network them together and make them interact with each other to achieve a common goal. Okay? So earlier the perception was people will buy some supercomputer and that'll be able to solve our problem. But soon enough, people realize that even if we keep on increasing the CPU, first CPU has stopped increasing. Second, second, the wires, the connectivity, the transfer of the data takes so much of time that no matter what your CPU or memory is, it's always a bottleneck. Okay, so that's where people realize that keep on increasing the configuration of your computer is not going to solve your problem. The complex problem and the big data problem can only be solved by using a distributed computing. And that's where the whole big data movement started. Okay. So all the tools are being rewritten so that they are compatible with distributed computing. Okay. Be it a database, be it a file system, be it a compute engine, that's where these all new tools are coming up. All right. So basically, one of the premise of distributed computing is other than utilizing multiple computers parallelly, dividing the work amongst many computers, other than that, the benefit of distributed computing is that you take the code to the data instead of transferring the data and bringing it to the code. On the left hand side, you can see that we have taken an X to the forest to cut the wood. In the second one, we have brought the wood to our garage to cut it. So the first one is the model which we follow, where we take our tools to the data rather than bringing data to the tools. Why? Because our tools are very lightweight. Most of the softwares are within, most of the data churning softwares are within 100 MB size, while most of the data when we deal in big data would be bigger than few GBs. All right. So keep asking question and I'll answer after every slide. All right. So the next thing which is important, and I have removed couple of V's from it. Okay. So the other way to figure out the characteristics of big data are these three V's. First is volume, second is velocity, and third is variety. Wo- So a big data can be characterized as because of the volume, it could be characterized because of the velocity, or it could be characterized based on the variety. Meaning your problem is due to the volume of data, and because of this problem you have to switch to the distributed computing. Meaning because the volume kept on growing, you could not solve the problem with a single computer. Instead, you started using multiple hard disks with multiple computers. That's when we say that our big data problem is due to the volume. Second is the velocity, where data our problem is due to data in motion. So for example, if you have to store 10 terabyte of data per day, okay, so for example, Facebook generates around 10 terabyte data per day. So if you have to store that kind of data, you would need lots and lots of storage. So that's the volume. Velocity is data in motion. How would you handle so many requests per second? For example, imagine this. When you open Facebook, at the time, there are at least 5 to 6 requests going from your browser to Facebook. Similarly, every second your mobile is sending a request to Facebook to check for the updates. So, if you imagine number of users of Facebook, they will be getting millions of requests per second, right? Now how do they handle that kind of motion? How do they handle that kind of data in transit? Okay, so so maybe your problem, when you try to characterize your problem, it might be related to the velocity, and to handle such kind of velocity you might need to have lots and lots of machine in parallel so that you can handle such amount of velocity. Next is the variety. Variety is data in many forms as well as problem in many forms. Please note, whenever we say variety, it's not only structured, unstructured data, it also the kind of problem are you trying to solve. All right. So variety is complexity of the problem as well as complexity of the requirement as well as complexity of the data. All right. Let's take a case of Google Maps. Even though when we have to find a path from one location to another in Google Maps, the number of requests which Google Map might be receiving is very low per second. But the problem lies in finding a location from one place to another within very small time. Okay, we expect the Google Maps to give us the response within say 5 seconds, right? To find that path in a state, in a country, within a very small time, they have to have they cannot solve such kind of problem using a single node, single computer. They have to have a distributed architecture. Therefore, whether your problem is due to the complexity of data or complexity of the requirement. Other complexity of the requirement could be find a pattern in the gene so that we can diagnose some disease. Even though data might be small, data might be say 10 gigabyte, but to find a pattern you have to do a lots of iteration in the data, and therefore the complexity of the requirement might cause your problem to become the big data problem. And therefore, to solve such problem, you might have to move to multi-node system rather than a single node system, meaning multiple computers in. All right. So any questions at this point? So Vikas is saying other two V's, please. I do not want to get into that. Those two V's are not really meaningful. They have been, they are like value and veracity. Okay. So both those V's are actually the deviation from these things. So I'll not be getting into that. All right. That's most like a PR thing, which these guys keep on doing. But these three V's are important when we are solving big data problem. So Nand Kumar's question is, even Teradata is multi-node system. How Hadoop is different? So Nand Kumar, the difference is in three things. One is how reliable is it, how scalable is it, and how how easy it is for doing it distributed computing. Okay, reliable, scalable, and distributed. Okay, so the architectural differences are there. Okay, and Teradata is definitely considered as a big data solution. All right. Now, as part of Spark, we solve two problems. One is velocity, other is variety. Okay, velocity is solved by Spark, the core one. Spark streaming, basically. Spark streaming solves the velocity problem, and variety problems are solved by MLlib and GraphX. Okay, while the volume kind of problems are solved by better solved by HDFS, HBase, Cassandra, MongoDB, etc. All right. So we are going to discuss these two aspects: the velocity of the data, where we have to do a lot of stream processing, handling a number of requests, and so on. Okay. Velocity is also handled by systems like Zookeeper and systems like other databases as well. But we are going to discuss Spark today. So Spark handles velocity and variety. So Vikas's question is Spark replacement for Hadoop? The answer is no. Spark only provides you the computational engine. Spark does not provide you a way of a way of storing data. Okay, but Hadoop provides you a way of storing data, and therefore Spark is not going to replace either Hadoop or MapReduce. Instead, it is going to work with both of them. While there is a compute engine as part of Hadoop, which we call MapReduce engine, which does the computing for you. Okay, so instead of Spark trying to replace any of them, Spark is filling a gap. The gap is to be able to churn the data at a fast pace, to be able to solve many different kind of tough problems. Okay, so we'll talk about these. All right. So Vikram's first next question, follow-up question is, then why we need Spark when we can use MapReduce of Hadoop? Brilliant question. I'll just take 2-3 more minutes and I have a separate slide for it. All right. It's a very important question. So, all right. And any questions up to this point? I hope everything is clear related to these V's, because this whole definition is probably most popular definition. But what we are going to focus more on the distributed computing part. All right. So these V's do not help us in, anywhere, but what helps us is the distributed architecture needed, the third point, and that we have to keep in mind all the time. All right. All right. Great. So Nand Kumar's point is, so big data is a concept and Hadoop and Spark are the tools. Yes, you can look at it that way. Big data is basically a characteristic, a kind of data, or when the data grows big and our problem becomes more difficult to solve using non-distributed kind of tools, then we start calling our data big data and our problem as big data problem. All right. I hope the definition is clear to everyone because there seems to be a lot of confusion on the internet with respect to the definition. Okay. All right. So a quick question to all of you. How many bytes are there in petabyte? Okay. Just to get a feedback. 1,000 terabytes. Okay. That is Santosh. All right. Yes. So that's correct. So I'll just move ahead instead of waiting for other answers. So yes, the total number of zeros in a petabyte are 15, while in a terabyte is 12. So it's basically close to 1,000 terabytes. But in reality, it's 1024 terabytes. All right. All right. Yes, somebody is raising hands, and all right. Good. 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 So, yes, let's move ahead. And we have got one interesting question from Shashank. I'll just keep your questions for a later time. All right. These are interesting questions. So, we have, are Spark and Storm similar? Then there was another question from Vikram. Then why we need Spark if we can use Hadoop? Brilliant questions. We will talk about these in a minute of time. All right. All right. So as the data kept on growing, As the data kept on growing, there were few reasons why the data has grown the way it is. The first one is the devices. The cell phone have been like a marvelous electronic device and probably the most successful electronic devices. These devices qualify all these three criterias, which is cheaper, faster, and smaller. Every hardware vendor has been fighting to make the hardware cheaper, faster, and smaller. If you talk to any of these manufacturers, they basically their main criteria is cheaper, fast, and smaller. And smartphones have been able to do that successfully. Okay, so smartphones have become cheaper, faster, and smaller. And everybody has that, and we all know that. And every second, we are generating a lot of data. We are generating a lot of data in various kinds of forms. Okay, in various kinds of forms, in the way, starting with in the way we are using apps, we are in the way we are communicating, all of that is generating data. And even when we are reading even when we are reading some update or playing a video, that's actually internally it's causing a transfer of the data and thus generating temporary data. So therefore, whether in the form of transfer or all kinds of ways, cell phones act as a data generation devices in the form of videos, photos, and everything. So, and the data is multiplied because of the connectivity of things. All right. And then we have these brilliant softwares today which keep us connected to everybody. All right. And therefore, all these three things combined are creating more and more data. And data is not necessarily a bad thing, it's a very important thing. We'll see it in a minute of time. So, when it comes to computing, what do you think the components which impact the speed? So, which components out of A to G impact the speed of computing? Anyone? CPU, memory read speed, disk size, native speed. What are the components which impact the computing? All right, all right, brilliant, brilliant. We have got really great answers. All right, all right. Okay, great. So most of you have answered correctly. Yes, it's all of above. The way we have been shown, or the way in the consumer electronics market we have been sort of told that it's the processor only which impacts computing, but it's the other way around. If you see any of your computers and if you see the usage of processor, it would be hardly 3 to 4%, not more than that. If it is beyond that, there must be something wrong. And if there is no application running, and if your CPU is taking some more than 3 to 4%, that means there's something wrong. Therefore, CPU is actually the second priority. The first priority is probably the memory. Second priority is probably the disk speed, not size, but disk speed. And then the disk size and the CPU. If you look at all of these components, then you will realize that all of these are part of the computing engine. Okay? If your data is in the network and you have to do the computing, then if your network is slow, then your computing is going to be really, really slow. All right. Therefore, the speed of computing is impacted by all of these components. All right. And when the data starts growing, any of these components would become such a big bottleneck that you cannot, no matter how you scale up your component, you will not be able to eliminate that bottleneck. Okay. There'll be and that's when you are not able to scale up any of these hardware, that's when you realize that the time has come to move to a distributed architecture, meaning buying more computers, connect them together, build a software which can run on all of these computers together to solve your problem. And that's when you say that you have converted your problem into a big data problem. All right. So Harshvardhan is saying, can you elaborate on IoT a little bit more? So here, if you see connectivity, right now we talked about people connectivity through Facebook and YouTube. So we have a question from Harshvardhan. Can you elaborate on IoT a little bit more? Okay, let me elaborate a little bit more. So when the devices, whether your cell phone, oven, printer, and monitors, your thermostat, and everything start communicating over the network to each other, we call it Internet of Things. Because human is not capable enough to interact and solve everything's problem. These things should be intelligent enough to take the decision right. And that's when we say that Internet of Things need when the devices become smart enough to connect to the surroundings and figure out the correct configuration for itself and transmit their data across the network, then we call such kind of network as Internet of Things. All right. I hope that answers Harshvardhan. So Satya's question is, in which area of big data industry, let me increase the font. Alright. In which area of big data industry are the demand gaps and what are the skills needed to bridge the same? Okay. So generally the demand gap is shown by the salary differences. And as of now, the demand in big data industry, specifically Hadoop and Spark and data sciences, is really high. If you look at the salary trends at Indeed.com, okay, Indeed.com, you should get an answer. All right. So generally, the salary is a mark of the gaps, and that is probably a better criteria than me coining out something. Okay. I feel that there is the demand gap in certain XYZ area, but that is not the true representative of the economics. You should have a look at the statistics with respect to salary. Okay, have a look at Indeed.com's salary trends. All right, Satya, was I able to answer your question? We recently had a career in big data where we also showed you the salary trends. Look at our blog on salary trends. Okay, there is a blog we have where career in big data, blog on career in big data. All right, all right, great, awesome. So we are moving on. Next is that fine, we have got big data. So what is so big deal about big data? What is so big deal about big data? All right. Now, the biggest big deal about big data is the truth. As in, if you have bigger data, you are more closer to the truth. If you have smaller data, you are less closer to the truth. Okay. So the as opposed to the previous behavior that we generally used to run a statistics on a sample. We used to do a survey of a smaller data because that was not technically possible. But now you generally have access to a large corpus of data. And out of that, if you take sample and you try to churn that, you may not be closer to the truth. But if you try to churn the whole data, then you are more closer to the truth. So every system which there are some systems which are analytic system where we want to have better results, so we churn bigger data. In some systems like stream processing, you do not have any other option than churning the big data. YouTube does not have any option other than serving the video to all the users. Okay. Similarly, if you are a startup, even though you might be a very small startup, you might be a small e-commerce company, still your traffic might grow really big suddenly if you do a PR or something. Okay. Therefore, you cannot avoid using a big data system in today's time. Okay. In certain cases you want more closer and more better results, and therefore you use big data systems. All right. So first is recommendation engines. These were the probably the oldest systems, and we will discuss a little bit more about recommendation engines. And then are various forms of analytics. One is your web analytics. You try to predict the behavior of the user. If you are running an e-commerce company or any other company who sells something on the web, you would like to understand why are people not buying your stuff. Maybe your price is not good. Maybe your design is bad. Maybe your website does not behave at certain point of time well. Or your website is having a certain kind of font which is not really legible for your target audience. All right. So there are many reasons why people might not be buying your things. For example, when we launched our course, we realized that our students are basically their mouse cursor is mostly on the price. So when we were deciding upon the price in the initial days, so we observed it that The as per our analytics, our course price does not seem right. So we tune the course price according to the people's demand and how much minimum can we afford. So analytics actually can help you whether you are running a small website or big website. Now when your data starts growing, if your traffic per day starts reaching to millions, or you are building some kind of analytics tool which has to handle hundreds of websites, then you do not have any other choice than building it on big data platforms, because you will have to handle a huge velocity, meaning huge number of requests per second. All right. So, and third is predicting demand. There are lots and lots of use case in e-commerce industry, and predicting demand is one of those. So, predicting demand as in how many how many requests are going to come today, and accordingly we should stack our inventory. Okay, so those kind of things are precisely have been a very difficult thing in past, but as of today, the companies like Amazon or Flipkart should be able to predict the demand very closely based on their past year trends and the trends at which the data is growing, as well as the trend at which their competitors are existing in the market. So when you combine all of the data together, your problem actually becomes big data problem. All right. Other than e-commerce industry, we can take few examples from telecommunication. They can figure out easily, and they are figuring out easily why customers are leaving them, or how what they do to stop customers leaving them. They can also do the network performance optimization by various kinds of handles, like figuring out the pattern of the traffic of various geographical locations. Similarly, they can do a calling record analysis of various users, and thus of giving a very optimized offers, such that it's a win-win for the customer and win-win for the telecom. All right. And then is analyzing network failure. So network failure can be predicted based on various kinds of signals that they receive from various towers and various equipments. Okay, so this is a common practice and they are actually doing it. And that can be done because the data uh, that is there in case of telecom companies is really huge. So you cannot analyze a network prediction failure without a big data system in place. All right. Recommendation examples are many. And because recommendation is probably the most oldest problem, recommendation is also called collaborative filtering. Okay. Recommendation problem is probably the point where the big data came into place for the first time. All right. So customer who bought this also bought that. Wear this particular dress with these shoes. So these are the examples of recommendation. Or if you are at Netflix, Netflix gives you the recommendation of which movie to watch. All right. So other than recommendation, there is a sentiment analysis problem where you so where there is a big data is being used in real time, so that you know exactly what is the response of the public towards your brand name. Okay, let's say you are McDonald, you are launching a new campaign and you want to figure out how is the impact of the campaign going on. Okay, so you draw two things, positive and negative, and then you draw that on a graph, and then you call that this is my real time sentiment analysis. For sentiment analysis in real time, you would require something like a Spark. All right, coming back to Satya's question. So okay, so in that ways, here is Satya's question. So in what ways is the data collected for analysis purpose? So the data that is collected for analysis purpose is in many ways. First is the web analytics. Okay, and that is like very deep, starting with starting with the cursor positions on the page, mouse cursor positions, mouse cursor positions, plus scroll positions, along with the clicks. Also, which pages have you visited? So web analytics for this is the kind of data we gather. Along with this, we also gather various other information across the various systems. All right. So data is collected in every form, and for that you need to build a platform in your organization so that there is no hesitation in gathering the data. All right. Eh, So was I able to answer, Satya? So one was web analytics. Other was if I am in a telecom, then I would keep a record of various calling records, your last position, last your various tower positions. I mean, which position were you at the last time? And there are many more data points which a telecom would be recording. If you are in a customer segment, you might want to keep a record of whole CRM. Okay. And whole CRM, and also the past historical behavior, historical historical data of various devices. Okay, whether you are in medical or anywhere. So all of this data that might sound, you know, the misuse of resources or wastage of resources, but if you think about the usages, there could be many more usages. If you think about things like recommendations, things like predicting the hardware failure, things like predicting the production rate. If you have a historical data, you would be able to predict a lot more things. All right. Great. All right, we have got one more question from Abhishek. When you talk about a storm, do you speak about Kafka also? Let me talk about this after a minute of time along with Vikram's question. So these are the two questions. I'll have to discuss it when we talk about later. All right. Now, next question is from, uh, I hope this is not disturbing for you. I'm trying to type it here so that everybody can see the question. All right. The next question from Satya is, how do you know which data is relevant to solve the problem at hand and which is not? That is very important. A very important question, and there is no straight answer to it. Okay? It is up to your imagination, up to your understanding of data, but as a general thumb rule, most of the organizational data you tend not to delete. Okay? There is no straight answer. Okay, but as a general thumb rule, we generally tend to store the data which does not have any other copy. We avoid storing multiple copies of the same data. All we try to do is we just keep the original data. You may never know what data could be of very highly use. Okay. And second part of your question is which data is relevant to solving the problem at hand and which is not. Okay, so this is again a very difficult question. So it first, when you try to solve a problem, in case of, let's take a case of that, why are our customers leaving? Okay, so you might start with listing down all the variables, starting with starting with the price points, starting with change in the website, starting with uh, the the competitor is doing better, their prices. And then you could also start with the customer support requests. So your customer support, your product quality, your product pricing, your market value, so all of these factors are your uh, might be impacting your prices, right? Therefore, you will try to put down all the things in place. Similarly, at the same time, you may want to see the demand gap in the market. Maybe there is some newer product launched by somebody because of which this problem which your product was solving is no longer there. You might also want to add a Google Trends into your whole analysis. So it's a very difficult question to answer, and it generally depends on your imagination and creativity to come up with all parameters, and then do a sort of a regression to form a correlation between the input and output and eliminate the variables which have no impact in the output. All right. It's a classic data. It's a classic data science problem. All right, we have got Santosh's question. I'm working on application performance management. We read the past data and predicting the hardware failure. Awesome, awesome. Yeah, so great, great. So this is Santosh. I'm working on an application performance management. We read the great. So this is, you can see that this is, even though in the beginning, in earlier days, historical behavior of the hardwares was not that important, so we never recorded this. But if you see these kind of brilliant tools which Santosh is talking about, then then you will realize that no data is useless. All right. Thank you, Santosh. Great. All right. So this was our sentiment analysis. Then there are many more big data customers, could be government for fraud detection, security, justice, healthcare is another very uh, lucky. I mean, I would say that because of big data, there are two sectors which have been very highly benefited. One is healthcare, other is other is the telecom. Their problems were already at such a huge scale. Along with e-commerce, healthcare, and telecom has been like the instant adopters of big data technologies, instant adopters of all the softwares which run on distributed computing. Okay, because they were having, no matter what uh, no matter what I mean, no matter how many supercomputers they had, they could not solve their problems, but now they're able to solve their problems. Most of their problems are related to huge data. So Vikram is saying, can it be used in supervision also? Definitely yes. Because in supervision, whenever you are supervising something, you can definitely use machine learning and online learning, online as in real time learning, to give the response. Okay, when the big data systems could be used in image detection and visual detection in real time, so supervision can also be. I hope I understood your question correctly. Nayak says that what could be the possible problems in analyzing social data, Facebook, and okay. So this is Nayak's question. What could be the possible problems? So when you are analyzing the social data, whether Twitter or Facebook, they involve all three things: velocity, volume, and variety. It becomes sometimes difficult to parse the data and transform into the shape which suits the tool. Similarly, the volume and velocity, all three things come into play when you analyze the social data. And and you reach to a point where if you compute the total amount of data when you try to analyze it, you will soon realize that you cannot use existing tool. The only reason why Hadoop was invented in first place, when somebody was trying to write a search engine and and they realize that they have hit the ceiling of their existing computing tools. All right. I hope I'm able to answer, Nayak. Great. Now, next question is from Nand Kumar. As per Gartner's survey by 2018, ouch, this thing suddenly becomes big and I need to make these questions smaller. All right. Yeah. So go down. Yep. So Nandkumar is saying that as per Gartner's data survey, by 2018, 80% of the data will be useless. It will be in the data lake. What does it mean? That means big data is not going to be useful. Big data is already fairly useful. Okay. So Gartner's survey, I might have to look at exactly which survey are you talking about and need to understand which point they're talking about. Okay. All right, so that is something to be done. I will have a take a look at it later. So Vikram is saying even social sites as well benefited by big data. That's correct. Very, very heavily actually. All right. Gururaj is saying, what is the difference between the data lake and big data? Is there any difference? So big data, I mean, when you start storing big data, whether in HDFS or in any other systems, we start calling it a data lake, where there are all form of data lying in there. All right. So this is just new terminology for data storage. Database was for only the cases where data was well structured, but in data lake, the data could be in many forms. All right. All right. So the first problem called volume was very well solved and is actually very well solved by systems like HDFS. What they did was they utilized many hard disks and from many computers over the network to provide scalable, fault tolerant, and very simple storage. There is a single folder scheme. To an end user, it looks like it's a simple folder system, single simple folder system which has got a backup, which is scalable, which is fault tolerant, meaning any of the computers go down, it can handle it well. No matter how big is the file, even if it's a 1 terabyte size file, still there is no problem at all because it breaks down each file into internally into pieces. Okay, so most of the volume problem is well tackled by HDFS. Now the second problem was the computational. Okay, ability to compute. First problem was to ability to store the data, and then comes the computational problem, which is how to compute, do some computation. Okay, so MapReduce was doing that, and MapReduce does the computation using hundreds of computers parallelly and does the computation such that the computation happens near the data rather than bringing the data to the code. The computation happens in the form of various snippets of code called maps and reduces. So user sends maps and reduces to the MapReduce engine. It executes it across the cluster and gives you the result, and that result is saved in HDFS. Okay, so this is like most simplified way to look at MapReduce, because MapReduce, if we go into the detail, is itself really a big deal. That's why we cover MapReduce in our Hadoop course in a very high details. It takes like 2 3 sessions to cover that. All right, so in a very simple way, when I say computation means very simple things, meaning there is my data. I want to translate it from one form to another. A computation can be as simple as find how many vowels are there in my data. A computation could be as complex as this, that find the standard deviation in billion numbers. Okay, or a computation could be that find the missing Okay, computation could be form form the hierarchy out of given cars. You are given all the cars since 1800s, I mean since 1901 till today, and you are told that these are the parameters of the car, and please form the hierarchy of these. Computation could be in very, very complex form, that given this voice, can you convert it into text? Okay, so computation, when we talk about computation, computation could be anything. All right, so most of this computation has to be broken down into MapReduce, and that runs on the whole cluster of computation. You see the whole big slab? It's basically containing small lots of computers in it, on which these maps and reduces will be executed, and they'll be reading the data from HDFS and writing it back. And this execution is such that that execution is always happening on the same computer on which HDFS is already running. All right, so this is the most simple way, but and we were able to do it successfully for quite some time. So Vikram is saying how HDFS is different from MongoDB and Cassandra. Both are distributed, fast, and reliable. Good question. So let me try to answer this. All right. Yes. So Vikram, for in MongoDB, you have to structure your data in something called uh, document. The way when you are trying to store the data in Cassandra, you have to convert your data into row by row and into tabular format. Here also in MongoDB, you have to form the data in that structure. Therefore, if you have got a folder structure, you have to figure out a way how are you going to convert it into the tabular format or in the MongoDB row by row format. All right. Therefore, MongoDB and Cassandra become sometimes a nightmare for for an organization when they start to push the data from various sources. They have to convert back and forth into into Cassandra and out of the Cassandra. And mostly in MongoDB and Cassandra, there is no simple tool like a file system. It's very difficult to emulate that part. All right. In case of HDFS, you can just mount an HDFS as a normal folder and start copying the data. Okay. While the data is being pushed to multiple systems simultaneously, but the end user or your developer in organization or your tools, imagine there is a video tool which can only read from a file system. Okay, in those cases, or you have got a surgical instrument, or imagine this, the x-ray system only writes the x-ray in a bunch of files, big folder, and into the file system. In all those cases, it becomes impossible to push the data back and forth to MongoDB and Cassandra. So it makes more sense to have HDFS as the default file system. All right, I hope that answers your question. Vikas is saying that why nowadays developer needs to know the complete architecture of MapReduce. I do not think it was done before. Yeah. So all right. So developer needs to know architecture because they have to convert their problem into MapReduce. Yeah, I agree with you that as the time evolves, as that's what we are coming to today also, that you don't need to get into the internals. You have got other tools which can convert your problem. You write your SQL, the system will convert it into MapReduce. All right. But when we talk about development, since most of the tools are still in infancy, I would say infancy because it had been hardly a year or two or three to for these tools, they're going to improve, and it is very important to know the technology under the hood. Okay, good questions. So Vikram is saying, but those are structureless. They sound like a structureless when we talk about MongoDB and Cassandra. When we say structureless, it means that it doesn't mean that it's a file system. It's still In MongoDB, there is something called collection. Inside a collection, you put document. Document is a JSON format thing. Okay, and a document has got a limitation of 20 MB. Therefore, they have their restriction. There is always what do you call is difference in the architectures, as in there is a very good term for this, um, impedance mismatch. Okay, there is always something called impedance mismatch between file system, okay, file system and say collections of MongoDB, and then file system and Cassandra. Okay, Cassandra has got tables in which you have to push the table. Although MongoDB has tried to form a file system tool which convert your files into collections by default, but again you have to use that tool to take out the data and push the data back. Okay, so if there is a tool which wants to use your document, your file, it has to first copy the data from MongoDB to local file system and then run on that. So that's always remains a big problem. All right. All right. So yeah, I mean, for example, if you have to store your music, it's in MP3 and you were pretty happy with your folder structure, then you start pushing that into MongoDB or Cassandra, and every time you have to listen to the music, you have to copy it back to the local file system and then listen it and then delete it and then listen to another song. So that's how the if you are building a dedicated system, you know your data well, then y- it's good to go for MongoDB. But if you have got variety of data, you do not know what all kind of data is going to come and what all kinds of data, all kinds of tools you are going to use. It does not it makes complete sense to have HDFS in place. So therefore, HDFS, which is a very simple file system, remains irreplaceable as of today. HDFS is irreplaceable as of today. So Satya is saying when it comes to big data, there are so many tools. Could you? It will be difficult, Satya, to cover that in that this one. Probably, probably that those ones we cover in our normal Hadoop sessions. We go through all of those. Okay. Today we are covering only the one which are relevant to the Spark systems, and definitely you'll get a lot of answers today. Now, Gururaj is saying how many nodes HDFS can spread? Is there any limitation on Hadoop file system can be installed? So yeah, this is a difficult question to answer because they keep on changing it every now and then. Okay. So earlier the limit was something like 100,000 nodes. I'm not sure about now. All right. Now there is a question from Shashank. Mishos, I'll cover this maybe later. I'm just putting it in this. All right, we'll talk about it later. Shashankar. All right, great. Let's move on. So we talked about HDFS, which was a file system, then the compute engine called MapReduce, which runs on Yarn. Okay, Yarn is your resource manager, which is behaves like a distributed operating system, takes care of which resource to allocate and which not to. But in case of MapReduce, the way MapReduce work, whenever you want to do computing, it reads from HDFS and it writes back to HDFS. If there are many MapReduces, then there will be lot of read and write happening from the HDFS, and that's why there is a delay. That's why when we say MapReduce is a batch-wise process, this is probably the reason, because reading writing from the disk from HDFS is fairly slow. Okay, already there is a time which it takes to read from the disk. On top of it, we have HDFS. Therefore, it is further slow because it's over the network, and that is why MapReduce remains as batch-wise operations. Okay, so in case of Spark, the story is different. The storage can be the RAM instead of the disk, and the RAM is 80 times faster than the disk. 80 times faster than the disk. All right. Therefore the therefore if you write some program in Spark and is utilizing the RAM entirely, your program might be more than 80 times faster. All right. Now, the shortcoming of the MapReduce, which is being resolved by Spark, was first, MapReduce was batch-wise. Every MapReduce cycle reads from and writes to the HDFS. There is a heavy latency in case of MapReduce. Con- Converting logic to MapReduce paradigm is a fairly difficult problem. Even the senior developers in my career have fumbled in converting a, a typical problem into MapReduce. I've seen even very senior developer having a hard time converting their algorithm into MapReduce. Third is, in-memory computing was not possible. Because the way MapReduce has been designed is that it'll give you answer no matter what, no matter how much time it takes, and it would try to utilize as minimum memory as possible. Okay, therefore MapReduce remains as great batch-wise solution, but not a real-time solution. So Shashankar's question here is, let me try to answer that. Writing such a huge data to RAM would require large RAMs. Yes, but there are two points to it. First, sometimes your data is smaller. Okay, let me change the order. First, you are utilizing the RAM of maybe 100 computers simultaneously, right? So his question is that such a huge, when I tell it that okay, there are shortcomings of MapReduce, it's sort of very uh, great at getting the work done, but there's a heavy latency because it reads and writes to the the HDFS every time you do a MapReduce. If you have multiple MapReduce phase, it's sequential and it'll take a long time. Okay, having your normal on an average, whenever you try to run a MapReduce program, it's an average response time is maybe 15 seconds or maybe 10 seconds minimum. Therefore therefore that was the problem. But now when I show this diagram saying in case of Spark we it utilizes the RAM. Now the question arises that isn't the RAM become the limitation? Answer is yes. It requires huge RAM, but first you can utilize the RAM of multiple computers. You're not utilizing the RAM of a small computer. Second, you can you can persist in the disk also. You can persist in the disk. All right. So if your RAM is not sufficient, you can save it in the disk. All right. Third is The kind of problem you generally solve, the kind of problem you try to solve on Spark is generally requires the response time requires very less response time. Okay, your problem might be really really complex, okay, for which you cannot do anything but do it in memory, although the volume is less. Okay, so the kind of problem which are great for, all right, so the kind of problem which are great for this selection Spark is when your volume may be low, but maybe low, but your problem is complex. You are running through the same data multiple times, say, such as finding a pattern, trying to figuring out recommendation, and so on. Even though your volume is lesser, volume is say 10 gigabyte or 5 gigabyte, is still the computation might be really, really intensive, RAM intensive, and read write intensive, and it might be very highly you require a quick response time. In those all scenarios, Spark really works well. Also, even if you persist in the disk, as in the way MapReduce behaves, still, since the way Spark has been designed, it is still faster when it does it on the disk. Now, next question from Santosh is in memory MapReduce is reliable compared to disk MapReduce technique. So the answer is no. Okay. Generally, the disk map reduces are far more reliable in the sense that in case one machine goes down, it will shift the computing to another. In case of, also the same thing has been taken care here also, but in case there is a power outage and the data is vanishing from the RAM, Spark may not be able to recover sometime. Okay, so but having said that, Spark has built really good redundancy, good reliability even over the RAM. Now we have got a question from Poonam. If we have real-time analysis, we should use Spark with any database. But what if we want to have bulk data to deal with? The processing cost time heavy. All right, let me just pick up this question and paste it here. That'll be easier. All right. So, okay, we have got a question from Poonam. We have real-time data analysis and we should use Spark with any of the database. That is correct. But what if we want to have bulk of the data to deal with? The processing may cost heavily as data is not present on Spark machine. Yeah, so that's correct because if your data is located somewhere else, then and you are trying to use a remote processing system, no matter how well distributed it is, how much well parallel is it, it is going to hit your remote data center, and therefore it is most of the cost is going to go in the network operation. So the general strategy is, alternative strategy is, you move the data to HDFS and utilize the Hadoop yarn to run Spark. Okay, because Spark can run on Hadoop yarn, and Hadoop yarn knows where is the data and accordingly will help Spark to execute its logic closer to the data. All right, so this strategy also work really well. If your data transfer over the network is costly, then this strategy might be really important to you. Okay, but do the computation, a back of the envelope calculation like how fast is your network, how much time it takes to transfer the data in real time, and how much time are you expecting as overall. That computation can give you a clear indication. All right. My next question is, Spark is in memory, then can we use Hadoop commodity hardware cause RAMs on data nodes not be very high? That's correct, Mahend. But still, so when we say commodity hardware, it doesn't mean that it's really low end. Commodity hardware are also okay. All right. And in case the RAM is not available fairly for Spark, still it will run fine. Even if it has got 10 MB space, it will only create partial data on that node. And it does not have sort of a minimum requirement. All right. But your doubt is correct that if you have data nodes with really small RAM, then they may not be very useful when it comes to Spark computation. Now we have BVD Rao's question. Can you tell me what is difference between SAP HANA and Spark with respect to the memory computing? All right. So the SAP HANA architecture I have not reviewed, and whatever documentation I have gone through, some of them they say that it's distributed, some of them they say that it's a hardware device. All right. So if you have access to SAP HANA, and they are not giving it publicly to everyone, if you have access to SAP HANA, the documentation, then you can compare the Spark, because I'll go through the Spark, and I'm really not sure because not a big fan of proprietary systems when it comes to the computing. All right. So Poonam is saying, in case we are trying to deal with the bigger data, then can we use some kind of cache? Cache is nothing but a database. Whether you talk about Memcache D, or you talk about Redis, or you talk about MongoDB, they all can be utilized as cache. Yes, that could be a solution. But again, if you are copying the data from remote, you want to make sure that your computation should run near to the data. Therefore, it makes sense to copy the data onto those systems where the data locality optimization could be done in Spark, and that can be well done if you are on Yarn, as in Hadoop. Okay, so probably the cache will result in a lower performance as compared to Hadoop when it comes to the computation near to the node. All right. Now, Shashankar's question is, does running Spark, very good set of questions. I am going to share all these questions with you. So, does running Spark on Yarn even enhance the performance as Spark need not take care of the. Yes, it does. It does. Reason being, it does improve. So, question from Shashankar is that how does the computation in Yarn improve if you run on Yarn? Okay, well, let me again state the problem. So you have this Hadoop infrastructure. In that Hadoop infrastructure, you have lot of computers. Those lot of computers are having data on them, right? And when you want to do a computation, you do not want to bring the data to the machine where your program is installed. Instead, you want to send this program to all the nodes and get the computation done on all the nodes, right? Near to the data, because transferring the data over the network is unnecessarily waste of time. Okay, and therefore it makes sense to transfer the code because code is far smaller than the data. So the question is, when we are running Spark is a computation engine which runs the logic which you gives to it, right? So Spark is a computation engine which runs the logic which you hand it over, but it runs that logic on multiple computers. Now figuring out which computer is something Spark needs to do, and that it does it using Hadoop's infrastructure, and that infrastructure we call it Yarn. Yarn provides all the details to Spark that hey, these are the computers available in the network, and the file you are trying to churn is located in these nodes. So it's better if you run the computation on these nodes. All right. So I hope that answers your question, Sasankar. All right, great. All right, coming back to our usual discussion. So Apache Spark is really fast MapReduce. It's an alternative to the compute engine which we called MapReduce as I showed you in the previous slide. It is, as per their claims, it is 100 times faster than the Hadoop MapReduce in the memory. I- Because if you run Spark absolutely in the memory, then it's 100 times faster, which is obvious because disk reads itself is 80 times. So you can clearly see that most of the computations are bottlenecked by the disk IO, meaning disk IO is the one, meaning disk read write is the one which takes most of the time. All right, it's not consuming that data. Now a- and this Spark is 10 times faster as compared to MapReduce when you do it in partially in the disk. Okay, and why is it so? Because of the basic assumptions where Spark will still try to utilize the available memory, available RAM properly to get the work done really fast. It builds on the similar paradigm like MapReduce, where you break down your logic into maps and reduces, but in a little different sense, something called actions and transformations. We'll talk about it later, and it is very well integrated with Hadoop. Again, Spark Spark is built up of many components. Spark core is the heart of Spark, which is a fast and general engine for large scale data processing. When you need to process huge data in on huge number of nodes, then Spark is your solution. All right. Ag- Wow, we have got more questions. So Mahen's question is, does that mean Spark uses HDFS? Yes. How to Spark compare with Apache Flink? Okay, that is something I will have to look at it. So which one are you talking about? So I'm just putting it as to be done. All right, let me just save it somewhere. And today's date is 18th August 2015, 8:30 p.m. 8:30. All right. So that is something I have to look at it. Which one you are talking about? Is this Spark support PCE flash and NVM flash drive? So answer is yes. I have not tried it, but if you look at the way these systems work, they do not delve into the hardware level. Instead, what they do is they utilize the hardware driver available on the local machine. All right. So basically, whether when you talk about native hardware behavior, they rely on the operating system. If operating system can read from these drives, they can read, right? Now, Howard's question is, what if the disk is SSD drive? Spark will still be. So, what if the disk is an SSD drive? Will Spark still be 100 times faster? So, so if the You are using MapReduce on, so probably your question is that if we are using MapReduce and Spark both on SSD, will will it still be faster? So the answer is it will be faster because the basic assumptions, design of MapReduce was to get the work done no matter how much time it takes. Okay. In case of Spark, the behavior, the tendency is to get done immediately. That's an architectural decision that Spark guys have taken. Get it done immediately. If it fails, give the error. All right. So in general, it is generally fast even at the SSD. You can have a look at their website. So it clearly tells. So Saurabh's question is, can we get this recording? Definitely. We'll be sending you the recordings. No worries. So Howard, was I able to answer your question? All right. I think it's a break time. Thank you, Nandkumar, for reminding. Let's take a break of 10 minutes and come back by 10:13 p.m. Let's take 14 p.m. IST. All right. Also, let me mark it here. All right. So we can start now. It's 10:14. Is everybody back? We can start now. All right. Is everybody back? Should we start now? Hello. All right. All right. Is my voice clear? Should we start? Because I've just changed the network from one to another. All right. All right. So we can start now, and I hope everybody is back. And great. Thank you very much. All right. Continuing with the questions, there are some really brilliant questions. So, uh, so the next question was that, yeah, in your Hadoop course, will you cover Hadoop cluster setup and administration? We will cover using Ambari. We will not cover without in the details. Okay, that is something that needs to be covered in Hadoop admin course, because here in this particular course we mainly focus on the developer related, and therefore we using Ambari, and maybe virtual machine is of course there is nothing to set up there. All right. So we'll help you with the how to set up the cluster immediately with Ambari, and that's how professionally it is done. Okay, that's how professionally it is done. Unless you are into the business of provisioning systems, unless you are Hortonworks or Cloudera or Mapr, otherwise you generally use tools like Ambari to provision the Hadoop cluster automatically. All right. So we will help you with the Ambari. Now, another question from Vikram is, I heard you cover Spark with Python, but why not Spark with Java, which is now? So we had some reasoning to go with Python, but we are not really limited by the language. Why we have chosen Python? First, it's quick to demo, so that a new learner who is coming for the first time to a language, they can quickly get hands on, and then they can get addicted to programming on Spark, instead of, because the whole agenda with Spark is to get the things done really quick. All right. Because in case of Java, people have to co- write the code in Eclipse, then compile it, build the jar, upload it to the cluster, then submit it as a job. So that becomes a longer cycle. And in the learning mode, we forget the main concept and we get busy into the syntax. All right. So one is it's quick to get hands on. Okay. That's the reason. And second was that most of the data scientists are focusing on Python because of the libraries. All right, because of the libraries. Okay, because a data scientist. Okay. Next is the, in case of we the other problem Python solved was it's easy to read for people who do not know either of Java or Python. This is the something which we conducted. So we gave the same logic to to people who neither knew Python or Java, so they could tell what does that logic work, what does that logic do if the code was in Python. So that was the reason why we are sticking, because of the readability. All right, and but again, we will focus on the concept more. And if you are from Java background, it should not be much of a problem to you. All right. Now, there is a question from Bhagwan. Bhagwan, we can actually discuss it over the email because other students might not be comfortable because it is related to HDFS. All right. In very simple words, HDFS doesn't care about what is the format; it just cuts it into the portions. Okay, it's your MapReduce job, which has something called input formatter, who has to assemble it and tries to create the meaningful sections. All right, you can drop this in email, okay, because that way I would know your email ID and I can respond to you. All right, nevertheless, I will put it on the forum. We have something called a forum, and on which I'll put it. All right. Harshvardhan's question is that, is audio muted? So everybody is muted except for me, because otherwise there are around 40 people in the session. Poonam's question is, can we consider HDFS as replacement of Cassandra or any other database in case we are having data local to Spark machine? Yes, I'll show you that. You will understand this part. You will understand that part. So actually Spark works with all of them. I'll show you in some time. So, Vikram, was I able to answer your questions? I think I covered your question. All right, all right. So, okay. So, all right. Since few of you all are also asking for this answer, let me just take. It will take me just 2 minutes. So, those who are, because HDFS is anyway going to be used for everybody. So, let me try to answer Bhagwan's question. Okay, so question is simple. The question is simple. Let's say you have to churn or process XML, JSON, or any other complex format, and that's stored in HDFS. And we all know that when the data is stored in HDFS, it is stored on multiple computers, as well as the file which we are trying to store, it is broken down into pieces, and those pieces are copied across the cluster. And every piece is also backed up. There are multiple copies of the each piece. Okay, piece as in each block. We break down into fixed size blocks. Fixed size as in 128 MB is current trend. Earlier it used to be 64 MB. Now the question is, does HDFS care about the format? In simple way, no, it doesn't care whether the file is XML, JSON, Java, or Java code, Java binary. It doesn't care what is it. Okay, it will basically split it ruthlessly. All right, it is the when your map reduce logic runs, that time we tell that, okay, here is my input formatter. This input formatter will try to create records out of this data, and then do convert it into meaningful data. It's the duty of input formatter to basically take care of the boundaries, take care of the slicing, and form the complete record instead of partial records. All right, I hope that gives the answer to you, but definitely I'll put it on the forum as well. Okay, so we have something called a forum in here, no big data dot forum. All right. So once you become a member, you once we register, it takes some time to get activated. So once you register on the forum, just ping us, and then we will make you active. All right. So the all right. So I'll just write it in a detail. This will be a better written in detail. It might take me 10 more minutes. So instead, I'll continue with the rest of the questions. Right. To understand this answer to this question, you might have to. All right. All right, Vikram. For this, you need to understand something called an input formatter. Okay, we call it input format. I can answer it better in a probably a separate blog post. No worries. All right. Yeah. So input format will try to read the raw data, try to assemble XML, and then give the result to your program. Okay. Same thing you can also imagine if you have plain text. Half of the line is in one file, rest half is another block, and which is located in another computer. But you want the whole line together. That assembling that is the duty of something called input formatter, which is part of your yarn or HDFS API. All right, it's not HDFS API. Sorry, it's a part of your MapReduce API where you provide the input formatter. All right, it might take a bit of time to understand that part. All right, so Spark Core, as we discussed, is a fast general engine for large scale data processing. All right, and Spark can run. Spark Core is basically the Spark. It can run on Hadoop, Hadoop's yarn, the same thing on which MapReduce runs. MapReduce utilizes Hadoop yarn. Hadoop yarn you can think of as if it's like an operating system to which you give the program and it can help you executing it over multiple nodes. That's what Hadoop yarn does for you. And similar is Amazon EC2. Spark can run on Amazon Elastic Computing Cloud. Similarly, it can run on a resource manager called Mesos. Mesos is also a resource manager like Yarn. And in case you are in a testing mode, you just want to try it out, you can download from their website and run it on your machine as standalone. You don't require Yarn or Amazon EC2 or any other system to just get started and test it. Okay. If you are running Spark or Hadoop or any of these tools on a single machine, these tools do not provide you any added advantage of computing if you are running on a single computer. Same work, if you do it directly, will be little faster as compared to running that on Hadoop if you are using it as standalone or a single computer. So Mahen's question is that do we not need Yarn to work with Spark when using Mesos? Do we not need Yarn to work with? No, not really. Mesos is not dependent on Yarn. Mesos is an independent resource manager similar to Yarn. Okay, the way Yarn has something called there is something called resource manager, then there is something called uh, uh, um, what do you call it's a kind of a task tracker where it keeps on working on all the nodes and get it done on the whole cluster. In the same way, Mesos has its own architecture so that it can get your work done using multiple computers. All right, it gives the resources. It tells Spark that these many computers are free, these many busy, we can get it executed there, and Spark says, okay, please execute it on those nodes, and so on. So all of those facilities are also provided by Mesos. Make sense to you? All right, Vikram, everyone, is everyone with me when we are talking about Spark? So Spark internally, if you think about it, it is going to execute whatever you tell it to on hundreds of computers, which are being managed by Yarn, Amazon EC2, or Apache Mesos. If you want to run it locally just for testing purpose, then standalone is good. All right, all right. So I hope everyone is with me. I am not, running faster or slower, or feel free to stop me if I'm going really fast. All right. So Spark can run almost on all popular cluster resource manager. Cluster means cluster of computers, and these tools are good resource managers. Now that was how Spark runs. And at the same time, Spark while running can read from many data sources. These data sources start from HDFS, HBase, Hive, and Tachyon, as well as here you can put Cassandra. Cassandra, it also runs on Cassandra, okay, and many more. All right. So basically, while Spark can run on any of these clusters, it can also read data from any of these databases. Every day, every now and then, Spark guys are adding, the developer team are continuously adding various kinds of input sources. All right. Therefore, Therefore, Spark remains Spark does not need to invent a storage system. Spark can very well live with any of the existing ones. All right. And when it's dealing with HDFS, HBase, or Hive, at that time, Spark can also utilize the locality optimization, as in it will run the code near to the node containing this data. All right. Next is, what is it for me? So Spark provides, other than the crude programming in the form of actions and transformation, the way in MapReduce you have the programming in the form of maps and reduces, Spark has a similar concept called action and transformation. All right, we'll go in the next slide into that. Now, other than the core one, just like Hadoop provides you MapReduce and Hive and whatnot, similar to that, Spark provides you bunch of libraries. It provides you bunch of libraries. These are not storage systems. They are just bunch of libraries. So first one is SQL. So you can basically run the SQL queries and internally they get executed on Spark and churn the data quickly. Similarly, Spark provides you this beautiful API for doing the stream processing. We will consider stream processing in a minute. So we'll just go one by one. So one is, those are the things. Let me just go one by one. So the core of Spark is designed in the following manner. The core of Spark is, there are three concepts which are part of Spark. First is resilience distributed data set. It's like a big array. The way you define array in your normal programming language, in the similar way, Spark gives you a concept of resilience distributed data set, which is equivalent to a huge array. It's a huge array in which few elements are on one node, few elements are on another node, next set of elements are on another node. Okay, so this resilience distributed data set gives us this huge array which we can use for various kinds of computation. And if you have been through any of the data churning systems, anything, be it anything, everywhere there is always this concept of an array. When you talk about a table, database table, and you say select star from my table, filter my rows by this, what exactly are you doing? You are trying to figure out only those rows which are matching the filter. And if you think about each row as a single object, then a table is nothing but a big array. All right. Similarly, if you are familiar with R, there is a concept of data frame. If you are familiar with Pig, there is a concept of data set. If you are familiar with Hive, again like SQL, it has that. Similarly, if you're familiar with MapReduce, for MapReduce, you always mark that this is my input data. Therefore, most of these data systems, they start with data. You write operators, you write all the code which runs on data, and that is how all of these systems achieve the data locality as well as data distribution without any hassle, because that's how the program is structured. Similarly, in case of Spark, the core idea is resilience distributed dataset. No matter what file do you read, it will be loaded as resilience distributed dataset. Okay, if you are reading a text file and you say text file sc.text file, then Spark will load the text file such that each line become an element of an array. So a text file when loaded on resilience dataset, it is a array of lines. Each lines is an object in that array. Okay, when we say array, it's basically like a huge queue. I mean, how can I represent array to somebody who is not very familiar with the programming concept? Array is list of things. Okay, so this RDD, you can see the sections. This is running on 4 computers. Some no, this data is on first, this data is on second, this data is on third, and this data is on fourth. All right, and the way you do the computation, you write your driver application and send the transformation or action to be executed on those nodes on that data, and then the action brings the data back to the Spark driver application. All right, so this is like core architecture. We can it requires a little bit more time, but I think this introduction should suffice. All right. All right, so there are a few more things to cover. So I think this question is answered. All right, let me try to answer Satya's question. Next question from Satya is that uh, can you explain Spark versus Storm? Storm is dedicatedly for doing the stream processing. Okay, and you have to write your logic in the form of bolts and which get executed on the cluster. All right, if you are looking for a system which gives you a latency of milliseconds, then you should go with the Storm. Okay, Storm is gives you milliseconds kind of latency, and Spark gives you fraction of seconds. I mean, around 0.1 to 1. Okay, so that's one way to do that. Second is, in case of Storm, you don't have very strong libraries available. Okay, and Storm is a very niche tool which is not general purpose framework. Okay, I mean the difference between Storm and Spark might take a little bit more time. Second is Storm has been into the use for quite some time. Spark has come recently, as in 2013, and just the difference between Storm and Spark is that Storm is limited in the functionality, while Spark has got far more bigger functionality in place. As you will see now that you have got these beautiful libraries, as well as in case of Spark, it's far more supported than the Storm. There is a proper company called Databricks who supports Spark, while Storm is not that well supported. All right. Now, the next question from Satya is the difference between library. Library is a list of functions, list of logic which you can call. Okay. Library means you can call the functions, and framework is an environment in which in to which you have to comply. All right, so that's the thing. So if we say MapReduce framework, that means we have to comply with MapReduce. We have to convert our logic into map and reduce. All right, and then hand it over to that framework and wait if it gives us the feedback. All right, but in case of library, you can call the functions. Although as you enumerate over library and frameworks, various kinds of library and frameworks, you will realize that the difference keeps on becoming more and more vague. All right. So yes, next is yes. You can say that library is a set of predefined functions. That's correct. That's a better definition actually. All right. So Mahesh is saying resilience distributed data set size. The size is based on how much is your input data. All right. How much is your input data? Next question from Mahendra is Spark streaming difference with Storm? The difference basically was this is only we are talking about Spark streaming and Storm streaming. Okay. While Spark was not really written for streaming. It just so happens that it is fast enough to be used to do the stream processing. Therefore, it's being used as stream processing. While Storm was only designed for stream processing. So, if you have to dedicatedly design a system in which your hard requirement is milliseconds, then you should go for Storm. Otherwise, if a fraction of second or up to a second is okay for you, then you should go for Spark. All right. I hope you get the difference. All right. Good. Very good questions. Any other questions as of now? Thank you very much. Now moving on with our discussion. So this was the core architecture. So effectively, no matter what program you write for Spark, whether in Python, whether in Java, whether in Scala, everything has to work with RDD. Okay, resilience distributed dataset. Everything has to load the input data into resilience dataset. Whichever data is big data is loaded onto the RDD, and then you keep on transforming it by launching transformations from the Spark driver application or launching actions. We will go into these details in the session 2 onwards, but that should be good enough. Now, similarly, all these framework, whether it's Spark SQL or MLlib, everybody converts internally the logic into transformation and actions. All right. Now, Mayan's question is better to learn Scala than Python? In my opinion, it should not matter much. Okay. I have gone through in my career in around 14 different languages. Okay. And I feel that uh, you should have good command of one language, which is general purpose one, and rest of the languages you can quickly get adjusted to. All right. So language doesn't do much. What does mean, what basically it provides you is almost the similar across different languages. There are only very minor differences. Okay. But it's the libraries, it's the libraries and your comfort level. Okay. So it's a probably the ever going debate, and we won't be able to finish this debate even in couple of days of discussion. All right. But in my opinion, rather than worrying about the language, I try to understand the concept, because the concept of RDD, actions transformation, is going to be the same. All right. All right. Good. Good. So I would say no comment. Personally, I like both of the languages. All right. Next is that Spark SQL. There was something called Shark earlier. So now it's Spark SQL. Essentially, it's not always feasible to keep writing the code in Python, Scala, or Java to even very simple operations, such as give me all those records where which contain this particular word. Now, if you are trying to do it in a core way, the normal Spark way, then you will start writing your Java code, and then you will load the data, and then you will write your transformation, then you will write an action, and then you'll get the result. All right. There'll be little too much to ask. Instead, instead, you could use simple SQL over your data, which is lying as RDD. On RDD, you can use SQL kind of syntax. Okay. You can use SQL kind of syntax. So on Apache Spark, you have Spark SQL, which can query, with which you can use the Hive query language as such. Okay. As well as user defined function and surdays of Hive can be used right away. As well as you can, once you have this up and running, Spark SQL is there, and you have Apache Spark, you can call Apache Spark from JDBC, ODBC. If you have an existing system which connects to some system and queries some data to give the results, same system can connect to Apache Spark and give the SQL and get the results done. All right. And therefore this Spark SQL provides a huge convenience as opposed to the the core of Spark. Okay. Internally, when you are executing SQL on Spark, it's basically converting it into transformation and action on top of RDD, and and it's getting the work done, right? All right. So it's not only a war of languages that SQL is better than XYZ, but it's also the way SQL is used. If you see, there are hundreds of beautiful BI tools which are irreplaceable. You cannot live without a BI tool. Therefore, and these BI tools, all of them support SQL. All right. And there are so many DBAs, there are so many architects, database architects, and all of them rely on SQL. Therefore, Therefore, Spark SQL has been a really big boon for the survival of big data systems. All right. The way Hive was quite successful, similarly, Spark SQL is also successful. Okay, Satya. Okay, let me paste the question from Satya. Satya is saying, how different is SQL Spark SQL syntax compared to MySQL or SQL Server? Not much. Not much. Basically, it's ANSI. It's called 80. I think it's called ANSI 80 standard. I need to look at this. So basically, it's compatible with the standard syntax, similar to HiveQL. It's very similar to your Hive query language, and is very you will feel that you are actually writing the basic SQL. All right. The way Hive had tried to be compatible with Oracle, be compatible with MS SQL, and by providing various kinds of data types. Similarly, here they have, in case of Spark SQL, they have tried to be very strongly compatible with Hive query language. Okay, Hive has solved the problem of structured unstructured data store by bringing something called a meta store, in which only the data definition is stored. Data is stored in usual databases. Same thing has been used by Spark SQL also. All right, good question. Now we have question from Mahen. Is it efficient to use Hive QL? Hive QL. Hive QL versus HDFS on top of Spark SQL, it is not. So it's the same thing. If you are running Hive QL or Spark SQL on Apache Spark, it'll be same thing. That won't be too much of a difference. Okay. Spark SQL understands both of those. All right. Again, so this is another question from Satya. Good question. And does Spark SQL have any limitations? That is, does it support modifying views, triggers, etc.? Good point. Yes. So Spark SQL, just like HiveQL, has also started supporting views, but I'm not sure if it supports modifying the views or not. Maybe you can do a delete views, but in case of HiveQL, they supported modifying views. So, all right, let me also review again. As per my knowledge, you could do the alter table, you could do alter views. All right, and triggers are not supported. Triggers are not supported. Reason being that the objective of Spark SQL is to become the analytics tool. Similar to Hive, Spark SQL also does not allow modifying the data. Okay, and hence triggers are also not supported in case of Spark SQL. Good question. Yes. So next question from Shashankar is that does Spark SQL support subqueries? It doesn't. Okay, it does not. But what you can do is you can use views instead of subqueries. All right, you can use views instead of subqueries. All right, very good questions. Brilliant. Moving on. So that was Spark SQL. Next is Spark Streaming. When we talk about Spark Streaming, first, what does streaming mean? When the data is coming at a very fast rate. Specifically, the queues. So specifically, when the data is coming in the queues such as Kafka, Flume, or sometimes in HDFS itself, if you are using Flume, it might be pushing the data into HDFS, and then the data you are reading from the HDFS, because HDFS is also an append only file system. So sometimes some of the systems keep on appending or creating more and more files into the HDFS in order to push the data at a very fast rate. Okay. So if you are trying to process the data which is coming in real time, okay, it might be your enterprise message queue such as 0MQ, or it might be your sentiment analysis which is pulling the data from Twitter continuously in real time. All of this data need to be processed. And when we talk about streaming, what does exactly it means? The data is coming on a millisecond, I mean a million record per seconds. Okay, and what you want to do is you want to churn the data in the form of windows. You convert the batches out of the incoming data. You keep on reading the data into a batch and then process it and then save it or display it or push it to your normal system for further processing. Okay, so basically reading lot of data per second and pushing it to the system is something that is called streaming, converting of fast data into batches and then processing those small batches to a meaningful results is something considered as streaming. All right. So when Spark was released, some people came up with an idea that Spark could be used for streaming. It could be used as a platform where people could push the data in a near real time. Okay, there is no such thing called real time. There's always a near real time. Okay, so a lot of people realized that they could use the RDD, the resilience distributed data set, to to pull the data, to receive the data from Kafka, Flume, or any of these these systems, and then process that data which is lying in resilience data set using our transformation and action. And the order in which the data is lying in RDD is in the form of time window. Okay, so that's what is called Spark streaming. And result of a Spark streaming can be stored anywhere, maybe in HDFS, maybe all of the data sets which we talked about earlier. Next question from Mahesh is, in Hadoop Hive queries internally runs on MapReduce. Coming to Spark SQL, what does it support internally? As I was telling you, it supports something called transformations, transformations, and actions on RDD, resilience distributed dataset. That's what it gets converted. Okay. So transformation action is similar to map and reduce in a way, but they are different. We can cover it later. All right. Now there's another question from Satya. So when it streams, does it generate near real-time analytics? Yes. So let's say you want to figure out how many users on an average are there on your website. Okay. So what you do is, as soon as a user comes in, you mark it that okay, there is a user, and then you wait for time window and keep on putting the users in this time window, and then you compute the count of the users per second basis, and that gives a idea that in this second there were these many users, in this second there were these many users. Okay, so that way you can generate a near real-time analytics. Yes. So Mahesh is saying RDD internally calls MapReduce. No. Okay, RDD is just representation of the data. Okay, transformation is a logic which you write and Spark executes it. Spark runs it. Your logic in the form of transformations consumes the data and produce another set of data. Or if you write action, it means you are trying to summarize multiple records into one. Okay, so it doesn't. Honestly, when we talk about this, okay, Spark does not depend upon MapReduce. Okay, though it depends upon Yarn, but it does not depend upon MapReduce. Mahesh, was I able to answer your question? All right. Next is that there's another beautiful library and probably the most powerful library as of today is MLlib. It's a machine learning library, but what is machine learning? Machine learning is the way human figures out pattern. Human figures out a relation between input and output. Given lot of inputs and outputs, human figures out, starts predicting that given this output input, what will be the output. Exactly in the same manner, machine learning also works. All right. It's a branch of artificial intelligence. It's for designing and developing algorithms and is based on empirical data. There are many use cases of machine learning. I mean, anywhere Anywhere people write algorithms, most of it can be automated provided we have enough data. If we have enough data, most of the logic can be automated. Okay? Most of the logic, such as how to figure out the image, person in the image, and all of that, can be automated. There are many, many applications. You can go through this list. All right. So MLlib can be utilized to do a lot of machine learning. Okay. So there are many algorithms available as part of MLlib. Many starting with almost SVT, linear regression, and logistic regression. There are all the basic ones. All the basic ones have already been built into MLlib. Therefore, when it comes to large scale MLlib, large scale learning, as in a machine learning which runs on a cluster of computer in a really fast manner, then MLlib is the only solution. Mahout is not a great way of doing the machine learning, but Mahout provides a ready-made algorithm list. In case of machine learning, MLlib, you can do a lot of operations, you have a lot of flexibility, and you can do a lot of raw programming using MLlib. So Shashankar's question is exactly what I was about to say. Yes. Okay. So MLlib is definitely more powerful than Mahout. Those guys are actually working on improving Mahout now. They're working on upgrading Mahout so that it can run on Spark also. All right. And it also provides a high level language kind of thing called pipelining, which basically makes the life of people who do a lot of machine learning easy. Okay, so in that way, MLlib is far more mature library than any other existing in the industry for which runs on big data. All right. Probably this is the default choice as of today. Next is the GraphX. GraphX is another beautiful and most powerful library available for processing the graphs. Graph as in, it's not a database. It's not graph database as you must have heard about NoSQL. It's not a graph database. It's a graph library. You represent your graph as in the form of RDD, in the form of vertices, in the form of nodes, and then you churn them. You try to find the path, you try to do all kinds of beautiful, you can do a lots of beautiful operations on that graph. Okay, so it can work seamlessly on both the things, one graphs as well as collections. It's very fairly fast. It's probably the fastest graph processing system available. Okay, and it provides a list of already existing library of algorithm, and there is a brilliant community. Okay, so as per the feedback I have got, I've used it and I've used others, and I've got that the GraphX is also the reason why Spark is quite popular. Okay, Spark is popular because of MLlib, GraphX, and Spark R. I will talk about Spark R. Okay, so the various algorithms which are already there, and you can build similar algorithm by yourself. Okay, so these are the few algorithms such as PageRank. PageRank is an algorithm by Google in which they order the pages, which to display first, which to display last. Connected components, as in finding connected components. For example, here, okay, this is one component, this is another component. Figuring this out is a difficult scenario a lot of time. Then label propagation, then svd++, the okay, then triangle count is used in case of graphics when you convert probably every surface into triangles, and then you try to count that. All right, so that's about graphics algorithm. And so then another important thing, which is probably the reason why people like Spark so much, is that they have come up with R on Spark, which is like a wonderful thing to have. Why? Because in R has got the richest set of library on machine learning. R has got the most exhaustive list of functions in statistics, in in lot of walks of life. Probably the biggest library I have ever seen in analytics. Okay, what is SparkR does is it SparkR makes it possible to utilize all those libraries on the big data. The problem with R was, although it has got the richest set of library, but the problem with R was that it was not able to run on multiple computers. And on a single computer, you soon hit the memory bottlenecks. R cannot operate beyond anything which is not there in RAM. Therefore, if you have got 2 GB RAM in your computer, you cannot operate on data bigger than 2 gigabyte. Therefore, R was not scalable. Now, Spark R puts that into picture and makes it possible to run your R program on the whole cluster. If your data is even 10 terabytes, you can still run the same logic which was written for few KBs in R. That is the beauty of SparkR. All right, good, brilliant, and all right. So Shashankar's question is, thank you, Shashankar. Is Giraffe similar to GraphX? Yes. Just that GraphX has got better support, and as we talk, the more and more algorithms are being written for GraphX as compared to Giraffe. Giraffe was pretty happy to run the basic algorithms such as PageRank, but beyond a certain point, uh, I mean, the adoption did not scale really fast. But for GraphX, it is inevitable. All right, I see a great adoption for GraphX. Now, next question from brilliant question. Thank you, Shashankar. Next question from Vikram is, what kind of work can we do with GraphX? GraphX can help you even the find path in a network of vertices. Okay, so you can find path. So GraphX allows you to represent a graph in the memory, and this graph is distributed. And what do we mean by graph? Graph has got these nodes as in the points, which are connected by lines. And so graph can be, many complex problems are essentially a graph. Whether your city contains streets and those streets are connected at various red lights or various kinds of cross sections, so all of that can be very well represented as a beautiful graph. Okay, so, and similarly, lots of difficult problems could be modeled in a graph. For example, parsing a huge data, parsing parsing a programming language itself is a graph problem. Similarly, there are innumerable many problems such as computing your Twitter rank, computing your page rank, computing the popularity, computing the sentiments. Almost all problems can be represented as a graph problem. And if you can solve it, then it is basically a big benefit of using Spark. All right, Vikram, was I able to give you an answer? Now, there is a question from Harvard. How does GraphX relate to MATLAB? GraphX relate to MATLAB in a way that similar kind of work was also done in MATLAB. Okay. Earlier in the back days, when there was no alternative to to solve the graph problem, so people used to use the MATLAB's library to solve the graph related problems. Okay. All right. Now there is a question from Satya. Are there any visualization tools for analysis? GraphX seems to be geared more towards web node analysis. Okay. So, I mean, as I was telling you, that GraphX is, I mean, it's not for graph drawing. All right, that your understanding is correct. So, visualize, when we talk about visualization, we always visualize a smaller amount of data. And for that, when we say smaller, it means few megabytes of data, or maybe up to a gigabyte of data. We do not visualize a terabyte of data. So essentially, the existing tool of visualization do a very good job, and there is no essential need of big data visualization tools. Okay, because at the end of day, we would prepare the summary, we would prepare some data which makes sense, which makes sense to the human eyes. Okay, and that data is generally not too huge. Okay, for that for that for that our usual tools are good enough. There is no need to invent the new big data visualization tool. Although in case of data visualization, the new there are chain of innovations are happening, but that does not those are not you know the those are not big data visualization. They run on any kind of data. All right. So essentially, for example, we call about D3J, data driven graphs, and D3JS. So those data driven diagrams are really really beautiful. So, but that doesn't that is not has nothing to do with any of the big data. Okay. So there is no visualization tool provided by any of them. Reason being, the existing other visualization tools are doing a very good job. Was I able to answer, Satya? All right. Good. Thank you. All right. So, any other questions right now? We have 15 more minutes. I have kept 15 more minutes for our discussion. If you want some particular topic to for me to expand some particular topic, I can explain it a little bit more. For example, what are the uses of machine learning? Let me just go through the first set of questions. So, first set of questions. Okay. So, is Spark streaming? Spark stream. First question which somebody asked: are Storm and Spark similar? Spark streaming is serving the same objective as Storm. Okay. Okay. So I think this got answered now. Kafka is a queue. Kafka is a queue. Is a queue which can be used organization wide for transfer of data. Okay, for example, you let's say you are an e-commerce company. At one end your vendors are updating various details, and other end those details need to be pushed to the website. Okay, so the the interfaces for vendors will be pushing the data into the Kafka queue, and on another end there will be tools listening to the Kafka events and responding to those by taking proper action. Okay, this way producer and consumer in an organization become decoupled. Okay, and there could be multiple consumers of the same set of data, as well as there could be no consumer for some data. And to process such queues parallelly, you generally require a stream system because data in Kafka is coming at really, really fast speed. Okay, now there are few more questions. So I hope I have answered all the questions. So I think this is answered now. So is Mesos alternative to HDFS? Answer was no. I think we talked about this. All right. Coming back to the new questions, we have a question from Vikram. How Ambari is different from Hortonworks or or the other? I think you're talking about OTHER, right? Other similar tech. All right, good question. So first, Ambari is part of Hortonworks actually. Okay, and other similar tech is your Cloudera Manager, and Ambari is open source. First, Ambari is open source. Second, it is again web based. While Cloudera is neither open source nor it's web based. For Cloudera Manager to run, you have to do an SSH and then run step by step. Okay. Reprovisioning, reprovisioning in Cloudera is little clumsy because you have to run it again. If you have to add more nodes, it becomes little difficult after some time. Okay. Next is that, all right. So these are the main reasons why I preferred Ambari over Cloudera Manager. All right. So Mahendra is saying that can you talk a little bit about Scala and if it is currently being used by any other projects? So Scala is being used, yes. Scala is being used by few projects, but and the feedback I have got from many people about Scala is that it's really good. It's really good for parallel computing or distributed computing. Okay, similar to Go, there is a language called Google Go, which is also trying to cater to the parallel computing environment. Okay, and it seems to lots of people seem to like Scala. It's strongly typed as opposed to Python, which is loosely typed, and and I do not find much of a difference other than having the syntax, which is very tuned to having the callbacks and very tuned for the parallel computing or distributed computing. But those same things are possible using Python also. So Satya is saying good. Thank you, Satya, for reminding me. All right. So I can show you something like, let me SSH to my server on Cloud Labs. So I'm logged in onto my Cloud Lab. This is the console, all right, of my Cloud Labs. That's running. It's running Linux and this particular version. So I've just logged in there, and from here I will log in. I will start my Spark user lib. This is where I've installed my Spark. It's a older version. So yesterday I had installed a newer version. So and installing was not too much of deal. This one which I'm going to run is basically uh, the newer version, but it's in standalone mode. Okay, so we have PySpark, we have Spark shell. So if you run Spark shell, you will have to write your statements in Scala. If you run PySpark, you will have to write your statements in Python. And if you run Spark R, you will have to write you will be able to use R. If you want to use SQL, Spark SQL, you will run this. For example, and in case you want to just run the examples, then you can use run example. All right. Okay. While if you are wondering where is MLlib and Spark, where is MLlib and GraphX, those are simple libraries, and you can basically use that library in PySpark as well as Spark Shell and as well as Spark Submit. Okay, so you can say import MLlib and then you can start using it. Okay, so this basically is running 1.4 of Spark SQL. And if you have to read a file, so let me just open my Hue console, or we can just say, let's say this is my array. Okay, 1 2 3 4. All right, this is my big array. Right now, for example sake, I'm just taking 4 elements. All right, now if I have to convert it into RDD, meaning if I have to load it on an RDD, I can simply say sc dot parallelize an a. This is my RDD. Okay, so now my RDD has been loaded into the memory. Okay, and now I can run various kinds of functions on it, such as I can run map. And let's say I wrote a function. This is my func. I'm just giving it a name. And what it does is it takes some value and adds that value with 4 and multiplies it by 2. That's the logic we want to run on every element. So we can say my rdd1 dot equal to, this is my new RDD I'm creating from my existing RDD. Okay, this is my data set. So I'm saying my RDD dot map means running a function on every node and then getting it executed. Okay, so it ran my logic on parallelly on every node. Okay, so you can see that every element, one was added with 4 and then multiplied by 2. Okay, so 4 plus 1 plus 5 into 2 is 10, 12, 14, and so on. All right, so similarly, if you have a huge data, you can run these maps and reduces in the form of transformation and action. So this was just a quick demo for all of you. All right, so now whether Spark is running on one machine or multiple machine, it's the same thing. I hope I'm sure you did not get it much out of it, because it requires at least 2 more sessions like this to get everything into action. So Shashankar is saying, does Storm use MapReduce? Answer is no. Why real time? Mostly they prefer Kafka but not Flume. It actually depends on, because in case of Flume, I mean, so Mahesh's question is why real time? Mostly they prefer Kafka but not Flume, because Flume has been recently designed first. Second, Kafka has been designed as a queue. Flume is just designed as an import engine. So Vikram is saying, so Hortonworks is now Ambari. That's correct. Does certification in Hadoop, okay, does certification in Hadoop slash Spark, either from Cloudera, has any advantages compared to other players out there in the market? So answer is yes, if you are joining a company who doesn't have people in big data already. So when a company who is hiring people into their big data teams and they don't have the bandwidth to take aggressive interview, they generally rely on the certificates. All right, so so but those people who are really serious, those companies who are really serious about the hiring, they generally don't care about certificates. Certificate is just one point of discussion during the interview. Okay, so other than that, I don't think it makes any sense. So Vikram's question is, will you cover MLlib while covering Spark? We'll cover MLlib's basics. We will give you a couple of demos of basic algorithm like how to do logistic regression, linear regression, so that you can get into the detail by yourself. Okay. Poonam's question is, can we consider HDFS as replacement of Cassandra or any other database in case of not really. Both are both have all of they have their own plus or minus. But honestly, if you are going with or if you want to churn your data using Spark, HDFS might make it little faster for the first time. For rest of the time it will be same because it's going to load it into RAM for some time. Okay. And HDFS is a folder system, right? It's like normal file system. And Cassandra is like a tabular system where each record is there. So if you have to store a video file or you have to store something else, you have to convert that into, you have to represent it like a table. All right. And similarly, you always require an API to deal with that. But in case you want to alter the data very frequently, you have to alter sections of the data, then Cassandra is far better than HDFS. Cassandra is any day better than HDFS if you have to frequently edit the data. All right. Was I able to answer your question, Poonam? So Ram's question is that what effort, how much effort does it take to become a data scientist from scratch? Actually, the data scientist definition is very vague, and it all depends how lucky you are and which company you are talking about. Okay, but to become a data scientist, it requires a fair amount of practice. Will you cover the Spark cluster setup? Yes. All right. Satya, that will be a little too much right now. So we can have this demo maybe later. So so Ram's question is that Cloudera is only certification for big data. No, there are MapR, there is Hortonworks, and there are few more. Okay, and we also provide our own certificate. Okay, so could you please tell us about the cluster you are using? We are using normal Hadoop cluster, and we are using DigitalOcean as opposed to the Amazon. Okay, and yeah. So all right, now coming back to these two more questions. What exactly is lineage concept in Spark? Which lineage are we talking about? You mean the data lineage? Data lineage is not there in any of these systems. Okay, that you have to build from at your own. All right. Do you think PySpark is better or Spark on R is better? So it all depends on what exactly are you trying to do. If your data requirements is very much related to analytics, then R is any day better. So in those cases, if you are, let's say, trying to quickly multiply two data sets and finding the Cartesian product, then doing it using R is far better. Okay, but if you are doing something which doesn't have a corresponding thing in R or SQL, then PySpark is far more flexible. You can do anything. Or Scala Spark is probably the most powerful thing. You can do anything with these. All right. Now, all right. Now, Sudhish's question is it a good idea to dive into big data technologies, though I am PHP developer? Yes, if you are interested in the backend. So, you in PHP, you represent the data which is lying on the web server, right? But then, how is that data prepared? How and similarly, in case of big data, you analyze the data which is gathered maybe from the PHP in MySQL or elsewhere. So that basically completes the loop. Okay. Vikram's question is, after attending your course, can we be able to get Hortonworks certificate? Yes. Okay. So our course is aligned to both Hortonworks and Cloudera, and therefore you'll be able to appear for both and you'll be able to succeed there. All right. Shashankar's question is it multi-node cluster? Yes. Our Hortonworks this thing is our Cloud Labs is a multi-node cluster. I can show you that. Okay. So Vikram's question is how much extra effort need to put to get certification? Honestly, if you are finishing all our exercise, then you don't require the any more extra work, but it all depends on you. All right, all right, great. So this is our multi-node cluster. So you can see that right now there are 4 out of 4 nodes alive, and as the load increases, we keep on adding more and more nodes. Great. So all right, that's pretty much for today. If you have any questions, feel free to ask it on our website. All right, and you can also post your question in forum. It takes a day for your account in forum to be activated. So thank you, Sudhis. I mean, you said it wonderful. I'm happy. And yes, we will continue to provide these sessions. We will try as much as possible to provide these sessions, probably because a lot of people like these sessions. All right. And just that feel free to write about it and spread the word about it. Yes, you will get the recording, Krishna. Thank you, Vikas. Thank you, Krishna. Thank you, Shashankar. Thank you, BBD Rao. I'm very happy. All right. Thank you, Ram. I'm happy that you find it excellent. Thank you, Poonam. Bye bye. Have a great day. And our upcoming sessions, I forgot to tell you, is this one. So you can see it on our website as well. And these are the upcoming sessions in the Spark and Hadoop. You can see both. All right. Thank you, Chetan. Thank you, Mahesh. Thank you, Mahendra. Thank you, Shudish. Uh, Thank you, Poonam. I'm happy that you find it knowledgeable. Thank you, Howard. Thank you, Mahend. You found it very informative and useful. Thank you, Satya. I'm happy that you found it great. Thank you, Harshvardhan. All right. All right. I'm happy that you found it wonderful. And it was a great session, great set of questions. And all right. Have a great day. There is one question. I will put it on the blog and will let you know. Right. There is one. question with respect to HDFS, okay, and that we can put it on the blog. All right, have a great day. I hope that you found it. Uh, I hope if you have any questions, stay connected. Bye bye. Have a great day. All right. All right. Have a great day. Bye bye. Bye bye, Satya.